Hello. Problem number 7 is pretty interesting, but also pretty technical. We have a quadrilateral, which is both cyclic and tangential. And we need to prove that its area is square root of the product of the lengths of the sides, A times B times C times D. So we now to proceed to the solution. But first let me recall what means that the quadrilateral is cyclic and what does it mean that it is tangential. Tangential is pretty much obvious. It means that all four sides and tangents of the same circle. And so if lengths of the sides are A, B, C, and D, it is known, it can be easily proved, and we shall see this in our proof below, that A plus C is equal to B plus D. Also, if we can circumscribe the circle around the quadrilateral, then it is said that it is cyclic, and if we have angles alpha, beta, gamma, and delta, then it is known that alpha plus gamma is beta plus delta. So that is what we know about this about tangential quadrilateral and this about cyclic quadrilateral. And we have now one quadrilateral which is both cyclic and tangential. There are now many of them, but the square is not the only one. Square is one such, obviously. And now we shall try to prove that the area, denoted by P, or it was maybe another letter, S, okay, I will denote it as it was in the document. So it will be S, so that the area is actually square root of A times B times C times D. So I shall start from tangential quadrilateral. So we will have, and now I shall try to put one better picture. So circle for tangents, and so this is the center of the circle. So we have that this is the radius, this is the right angle, so we have perpendiculars to all other sides and r radius again. Here perpendicular r, okay, I can't draw that precisely, but you understand this is again perpendicular and R. And actually I will denote this like alpha, beta, gamma, delta, and let me this be sides A, B, C, and D. So if I connect center of the circle with vertices of the quadrilateral, then I have two equal triangles, two congruent triangles here and here. So this is alpha over 2 and alpha over 2, 1/2 of the alpha. And similarly here, if we connect, we have beta over 2 and beta over 2. If we connect here, we have gamma over 2 and gamma over 2. And if we connect here, we have delta over 2 and delta over 2. What we want to conclude? I want to conclude that this length, sorry, maybe I want some other color, that this length 2 is actually R times cotangent of alpha half. So actually from this right squared, from this right triangle here, cotangent of alpha half is this, is actually this side over this side, and this is exactly what we obtain here. Similarly, this one will be also this, we already said that these are two congruent triangles, so this will be R times cotangent of alpha half. And now similarly we have this and this, these two to be R times cotangent of delta half, but because of sorry, I didn't put actually the right completely above. This sum of alpha and gamma and beta and delta is actually equal to two right angles to 180 degrees. So actually this is also R times tangent of beta half, because delta is 180 minus beta. Similarly, this and this are put times cotangent of gamma half, and that is actually R times tangent of alpha half from the in the same way, and also these two sides here are R times cotangent of beta half. So what we obtain here, if we sum this and this, we obtain A. So the side A has length equal to R times cotangent alpha half plus cotangent beta half. The side B is equal this times this, which is actually R times cotangent beta half plus tangent alpha half. C is equal to R times tangent alpha half plus tangent beta half, and D is equal to R times tangent beta half plus cotangent of alpha half. And now we will try to multiply all this to connect with this expression here, but actually I shall multiply for simplicity A times C and B times D. A times C is R squared. So we will, this is R times R, and now I will multiply this and this, and I use that tangent times cotangent is 1, so this times this cotangent alpha half times tangent alpha half is 1. This times this is also 1, so I obtain 2 plus, and now this plus this, so tangent alpha half cotangent beta half plus cotangent alpha half tangent beta half. And B times D is similarly R squared 2 plus tangent alpha half tangent beta half plus cotangent alpha half cotangent beta half. Okay, and if I now okay, and if we multiply these two, we will obtain this product here. And so we need to show that this product is actually the square of the area of the quadrilateral. And how we can obtain area? What is S? What is area? We will sum 4 triangles. Okay, let me now switch to green. We will sum the area of this triangle. Okay, with area of this triangle here, with the area of the next triangle here, and the fourth one. And actually the area of first one is 1/2 A times R. The second one has area 1/2 B times R. The third one is 1/2 C times R, and the fourth one is 1/2 D times R. And actually S is equal to 1/2 R, A plus B plus C plus D, And actually, if we substitute these equations above here in this formula, we will obtain that area S is equal 1/2 r squared, and we will obtain the sum of tangents and cotangents of alpha half and beta half. Tangent alpha half plus tangent beta half plus cotangent alpha half plus cotangent beta half. And so I will now simplify the notation. I will denote x to be equal tangent alpha half and y to be tangent beta half. And then area S will be equal to 1/2 r squared times x plus y plus reciprocal value 1 over x plus 1 over y. This is S. And sorry, I am mistaken. In this S we have, when we sum all, we have two. Sorry, I will put this in red that you can see what was my mistake. We have 2 here, 2 here, 2 here, 2 here, and this cancel with this 2 here, so there is no 1/2 here. There is no 1/2 here. And the product A times B times C times D is actually r to the 4th 2 plus okay, this is x over y plus plus y over x. This comes from this, and another square, and another one is two plus 2 tangents, so xy, plus 2 cotangents, so 1 over xy. And so we actually claim that s squared, sorry, I will put in red, that actually s squared, which will be actually this to the 4th and this to the this squared, is equal to that product. Such way we will prove that s is square root of the product. So we actually need to show that this is equal to this. We need to show that x plus y plus 1 over x plus 1 over y squared is the product of two parentheses. One is 2 plus x over y plus y over x, and the second one is 2 plus xy plus 1 over xy. And I will leave this to you to verify, because this is a direct calculation. You simply multiply two squares on the left and on the right to show that the left hand side is indeed equal to right hand side for any x and any y. So this is algebraic identity actually, and we have thus proved the formula that the area S is square root of A times B times C times D. Thank you.